Lesson 3, day 2, condensing logarithmic expressions. The entire reason that we want to condense logarithmic expressions is that we're going to be solving equations involving logarithms. And if I have this in an equation, it's a lot easier to condense the logarithm and then solve the equation. So I always want to try, when I have multiple logarithms, to condense them to one. So letter A is product property. Does anyone have an answer for letter A? Because you know it's product property, so it's going to be one logarithm, right? What are you going to do with the stuff that's in them? Multiply them. But first, you have to take that exponent and move it up. So this is going to be log base 8 of xy cubed. How many people got that? Good, good. Any questions on that? You can do it in 2 steps. If you want to first move the exponent, that's fine. Number 2, some people get stuck on this. Technically, what's happening is both of these are subtracting. So you could think of this as minus. I don't think of it this way for the record, but you might. Log y plus log of z to the 4th, because I'm moving that exponent up. The plus means I'm going to do what with the y and the z to the 4th? Multiply them together. But where are they going to appear since they have this minus sign in front of them in the denominator? I don't do all this. I basically say, okay, let's start by moving our exponents. So there's a 4 there. And then which ones are positive? Those ones will be multiplied together in the numerator. Which logs are being subtracted? The logs being subtracted are this one and this one. So those factors will appear in the denominator through the quotient rule. So then this becomes log of x squared over yz to the 4th. Raise your hand if you got that one right. Less people, but still a good amount. If you didn't, it's okay. Are there any questions on it, or are you guys good now? Did you have a question?
Yeah. Can you also write it log x squared over log y to the 4th?
No. Because our rule for quotients, that's a good question. Remember, so when we have a log divided by a log, we're really doing change of base formula, right? Log base b of a is exactly equal to log of a divided by log of b. It changes the base so they both have the same base. The quotient rule says that if we have some factors in the numerator and some factors in the denominator, we can separate them through their own logarithms with subtraction. So when we're condensing, we're working this direction. We should only have one logarithm, and the division should happen inside the logarithm. Yes?
If on the bottom, can you just like put y as
So it's like y times z to the 4th, but they're both in parentheses?
Yeah.
You can. You don't need to, because neither one of them has a plus or minus sign. But if I were going to put any parentheses, like you can do that. You're asking if you could do this, right?
Yeah.
You can, but you really want to, you can drop them because there's no plus or minus signs that really separate them. They're just being multiplied together. And so that's showing through just having them right next to each other. So you don't have to do that. But I don't think I wouldn't necessarily mark it wrong, because technically it's not wrong. It's just not looking as nice. All right. So now we're going to look at letter D, because I asked you to try letter D. All right. Anyone think they have an answer for letter D that works? Uh-oh. Not many hands are going. Anyone want to take a random guess? I won't call you out. You want to take a guess? Go ahead. What do you think it is?
Natural log.
Sorry, I'm having technical difficulties. I may just have to switch to the camera. So you have natural log of I messed up, sorry. X minus 4 to the 6th. We're going to pause this and switch. I can't do this anymore. All right, so you said x minus 4. So you basically moved this exponent up to that, and then this exponent up, and said since it's a plus sign, they're just going to be multiplied together. So I've got x minus 4 to the 6th and x to the 3rd. You could put the x to the 3rd either on the right or the left of it, and it's good. Don't distribute this 6. Why don't you distribute this 6? Because it's its own term. There's subtraction in there. It's its own factor. There are 2 terms in there, so I can't do that. If I were going to do that, I'd have to expand it. And you'd probably want to use binomial expansion to do that. I'm OK with you leaving your answer like this. OK? All right. Any questions on letter D? So we don't have any division inside the logarithm because there was no subtraction of logarithms. Let's take a look at letter C. For letter C, I'm going to move this exponent of 1/3. I'm going to leave the sign there, though. So with that sign, I know that that sign, the minus sign, means that there's going to be division inside the logarithm. So and this 4 I'm going to move up on top of the x. So the positive log, that factor, x to the 4th, will be in the numerator. So I've got log base 3 of x to the 4th. Oh, crud, I should have left more room. OK, I'll still be able to fit it in. Over the quantity x plus 6 to the 1/3. What does this really mean? What's that mean? Cubed root. Fractional exponents are really roots. So that's over the cubed root of x plus 6. X plus 6, again, there are 2 terms, so it is its own factor. I'm not going to put that on both of them, but rather the whole thing. So I have this, and so I've done my job condensing, but technically I'm not really done. Because am I allowed to leave a fraction with a radical in the denominator? No. So you remember back in geometry and even in algebra 2 or algebra 1, you had some things like this, and you're like, oh, we're supposed to rationalize that denominator. What did we do to rationalize this denominator? Multiplied both the top and bottom by square root of 2 to rationalize the denominator. That gave us square root of 2 over 2. It gave us a 2 down here because there were 2 factors of 2, so that it was the square root of 2 squared. This is not the square root. This is the cubed root. So how many factors of this do I need? 3. Well, there's already 1 of them, so I need 2 more to have 3 factors of x plus 6. But whatever I multiply the bottom by, I have to multiply the top by, so I don't change the value of the fraction. So unfortunately, the top, we're going to have to do something more. But the bottom is nice because we took the cubed root of it, right? So now I have log base 3 of, I'll fill this in a second. In the denominator, it's just x plus 6. We don't have any radical down there anymore because x plus 6 to the 3rd, take the cube root of it, is just x plus 6. This, however, is x plus 6 by x plus 6. So that's x squared plus 6x plus 6x, so plus 12x, and plus 36. So I have that, and then I have an, that's all under the cubed root, though, so I can just write x to the 4th cubed root of the x squared plus 12x plus 36. So this has been simplified. I can't do anything more to this. We've even rationalized the denominator. You're not going to get a ton of points penalized if you leave your answer here, but you will probably have at least a half point taken off because it's not completely simplified. Yes?
On the top row, why does it become never mind?
Are you sure? OK. So why does it become all this stuff?
Yeah, I didn't know like why.
Yeah, because it's,
Like I saw the roots.
oh, God, yeah, because there's 2 of them, so I had to multiply what was under both of those. Tessa?
Why couldn't you just write like in the denominator x plus 6 to the 1/3?
Because fractional exponents are the same thing as radicals. So even though it's not written as a radical, it should be, I need to rationalize it. Also, when we were expanding yesterday, we took things that were a square root or a fifth root or whatever, and we changed those to fractional exponents as part of our expanding to change the way it was represented. But whenever we have a fractional exponent, the only reason we write them as fractional exponents usually is to help us simplify the problem. Otherwise, they should be written as radicals in radical form. Sorry, I couldn't find the page here. So we did need that. Yes, sir? No, it's because there's a radical down here. And the rules of radicals are you can never have a radical in the denominator or a denominator under a radical. So we have to do something to simplify it.
So anytime you have that, you need to
Anytime you have a radical in the denominator, you need to rationalize it. In this case, it was a cubed root, so I needed to do 2 more factors to get 3 factors for it to escape. Had it been a square root, I would have just had this times square root of x plus 6 on top and just x plus 6 on bottom. Letter E. Letter E shouldn't be too bad. There are how many logarithms? 3. How many of them are positive? 1. See if you can simplify letter E, and then we'll look at letter F together. All right, who has an answer for letter E? Anyone? Nobody? Pete? Okay. Joe. And if you don't get it right, then we'll say it was the other Joe. Okay, all right. Natural log, yep. Okay. Okay, so yes, the denominator would be x to the 4th and x minus 1. I would accept that. You should, if this had an exponent also, I wouldn't worry about expanding, but because it's just this, I probably would expand to simplify it. But I would accept either one, okay? So that's good. It's just if we have a radical, we've got to take care of that. Letter F is the one that a lot of people get annoyed by because there are how many terms? 3 terms, and I want that to be written as 1 logarithm if possible. So there are 3 terms, I want it written as 1 logarithm. That means I need them all written as log base what? Log base 5. Well, what's 1? It's log base 5 of 5. And then this is minus log base 5 of x to the 4th plus log base 5 of y cubed. And so now I can combine these. How many of these logarithms are being subtracted? 1. So that means that factor, x to the 4th, will be in the denominator. The other 2 will appear in the numerator as a product. So if I just took that away, I'd say, oh, that plus that, I'm going to use the product property. So I have 5y cubed over x to the 4th. Now, I've had some people who say, well, Mr. Ritter, can I put the negative on the exponent? You can. I don't prefer to do it that way. It complicates things a little bit, but you can. It does still make sense. To some people, it makes more sense. So they look at it as this, x to the negative 4th. And you're like, well, how does that work out the same? Well, it's all product now, right? So they're all the products. So it would be log base 5 of 5 times x to the negative 4th times y cubed. Except, are we allowed to have negative exponents in our final answer? No. So then you're going to do what with that in the end anyhow? Move it down. So you're going to get the same thing, but it's going to take you an extra step. But if that makes more sense to you and you can consistently get it right that way, then go ahead and do that. There was one other thing I was going to point out to you. Oh, I know what it is. If I had, I'm going to go up to the top. Well, you probably don't have room up there. I'll go over here. If I have 2 plus log base 5 of x, that's not a 1. There's 2 ways to do this. What's one way I could do that? They all need to be condensed, right? So this is log base 5 of what? Anybody know? 25, because the answer is 2. So 5 squared, the answer is the exponent. 5 squared is 25. Now, I've also had people who have separated. They're like, I don't want to think about exponents. Then write it as this. 2 is really 1 plus 1. Now I can do log base 5 of 5 plus log base 5 of 5. I think that's more work, but you can do it that way. All right, yes?
Say for like F, is it wrong if you put log base 5 on top and bottom?
Yes. So back to our quotient rule, which is that when I'm when I have the log of a fraction or of a quotient, I have separated it into 2 logarithms, right? Using those factors that were in the quotient. If I'm going in the reverse, I need 1 logarithm. The positive one is the factor on top. The negative ones are the factor on bottom. If I'm dividing a log by a log, I'm actually doing the change of base formula. And that's not what we're doing here. Does that make sense? Okay, so be careful about that. All right, so this is it for today's notes. We're going to do a concept check in a second, and then you have some practice problems. Let me press stop on this.